Good evening, everybody. Give me a second to get set up, guys, and we will get into tonight's live stream. Okay. All right, who's in the room? All right, and the volume should be down. Who's in the room? Indicate the location and the test you are taking. And can you guys hear me? Most importantly. Give me 1 second. Still here in the room. I'm not liking how, like, this shirt was like a little bit too dark. So, yes, I'm changing shirts. I'll just be a moment. You guys can send your questions to KIENOTHOMAS@gmail.com. Just be a minute here. I didn't think that shirt was going to just be so blah. Cody, how are you, buddy? Who else is in the room and what test are you preparing for? And Cody, can you hear me? Doing well, thanks, made it. All right. Okay. There we go. I like the contrast of that shirt. All right. I don't know why. On a particular camera that I'm looking at, it just feels better. Okay. All right, let's get those questions sent out. And we will start looking. I had a subscriber email me and tell me that it would be nice if I focused on a little bit more of things that you will be required to know in aviation pre-flight indoctrination. Now, I do a prep course for that, and you can go to stemwithkino.com if you like information. Or you can contact me on Skype at kino.thomas if you want to know more information about it. But I think I'm going to touch on some topics. So that's going to be my focus. I'm still going to be hitting SIF things, all the other test things, but this is where we are. So let's go to the email and let's get our first question. All right, it's taking a little bit of a minute to load. There we go. All right, I've done this one before, but you can never do too many word problems. So basically, and guys that have been in with me or working with me for a while, coming to the live streams for a while, I've seen this question executed. The question states, an aircraft carrier made a trip to Guam and back. So we'll pause for a second. Well, not pause, but you read a line and you diagram. So this is your start point, and B would be Guam. So what we know is we went there and then we came back. Another thing I'm going to do is I'm going to write D for distance, R for rate, and T for time. D for distance, R for rate, T for time. All right. And the reason why I'm doing that, because we have a distance, rate, and time going in this direction, and we have a distance, rate, and time going in that direction. And let's not forget our formula. Distance equals rate times time. All right. So as long as we have two factors, we're going to be able to figure out a third factor. All right, so the next question. The trip there took 3 hours, and the trip back took 4 hours. So the trip there took 3 hours. The trip back took 4 hours. 4H. It averaged 6 kilometers per hour on the return trip. So I'm just reading the line, and I'm diagramming. That's all I'm doing. All right. Find the average speed of the trip there. So we don't have that information because we don't have two pieces. But here we have two pieces. And like I said, as long as we have two pieces, we can get the third part. Distance equals rate times time. Well, what is the rate? 6. What is the time? 4. 6 times 4 is 24. So we have 24 kilometers. So the trip there took 24 kilometers. The trip back is going to take 24 kilometers. And so we can insert 24 kilometers here. And in order to find rate, then what we need to do is, all we need to do is just divide 24 by 3. And for all my people that have not done long division in a while, I hear something chiming. All right. So I did this backwards. 3 is here, 8 should be up there. Because 3 times 8 equals 24. So 8 kilometers per hour is the rate that it took to get there. All right. So don't be discouraged by word problems. All right. If you just process them line by line, you should be okay. And they should not be a major challenge to you guys. All right. Going to the email, looking for something interesting. Boom. All right, so this guy already. I think one thing that we don't cover a lot of are linear equations in our live stream, and so I'm going to talk a little bit about linear equations until you guys find questions that you're having difficulty with, and then I will just process them. But I'm finding like a lot of times when I'm Skyping with someone and I'm talking about linear equations, they kind of have that deer in the headlight look. All right. All right. Cody, I think I got part of your... Hold on, maybe I didn't get it all. I'm sorry, guys. But we are going to touch on linear equations, nonetheless. But, gosh. Okay. Got it. I haven't done this in a while, but let's try it out and see how it works. Okay. A field can be plowed by 12 machines in 7 hours. Okay. So that's like the baseline that they give you. A field can be plowed by 12 machines in 7 hours. So we have 12 machines. And it can be plowed. These 12 machines are plowing in 7 hours. All right. If 8 machines are broken and cannot be used, how long is it going to take? Wow. How many machines? 8 machines? The writing is super small. All right. So, yeah, 4 machines are broken. If 4 machines are broken, so we go from 12 to 8. And boom. So 12 times 7 equals 8 times x. 12 times 7, 14, 84, 8x. And 8, 1, 0, 4, and 40 comes down because we're gonna actually down 5, 45. What happens if 5? No, it should just be 84, 0. All right, boom. So 10.5 hours, which is option D. The answers were 7.5, 8.5, 9.5, and 10.5 hours. So you take your machine, it's like a proportion. And Cody, what was the answer in your book? Should be D. So while I know when people see this question 9 times out of 10, most people do not know how to approach it. So you take your 12 machines in 7 hours, and we have 8 machines, and we don't know. They're saying, like, if we lose 4 machines, then how long is it going to take us to get this done? So what you need to do is you need to multiply 12 and 7, and that will be equal to 8 times the unknown number of hours, because we don't know. Now, I know my chicken scratch was probably hardly legible, but what we did was we multiplied 12 by 7, we came up with 84. And then all we needed to do was divide 84 by 8. And for my people out there that are having trouble with long division, I'm going to make this cleaner. 84.0. I'll put the 0.0 because I want for accuracy. 8 goes in 8 one time. We put our 1 there. 8 times 1 is 8. We subtract 8. That's 0. The 4 comes down in this round. How many times is 8 going to 4? 0 times. Since we have a decimal here, we bring it up for our answer. Right? So 0 times. We put a 0. 4 comes down. Now the 0 comes down. And we put our 0 there. How many times is 8 going to 40? 5 times. So 10.5 hours. Boom, boom, boom. 10.5 hours. So to recap, how many a field can be plowed by 12 machines in 7 hours? If we lose 4, how long is it going to take to plow the field? Well, if we lose 4, it's going to take us 10.5 hours instead of the normal 7 hours. All right, so that was a good question, Cody. Fire those questions away, guys. In the meantime, I'm going to talk about linear equations. Okay, so this normally works out a lot better on Skype because then I can screen share and stuff like that. I cannot screen share and live stream, but we will get through this. So, linear equations. When we have the Cartesian coordinate plane, remember that old thing you guys used to see in school, and we had an x-axis and we had a y-axis. Alright. This is the Cartesian coordinate plane. And we have a set of ordered pairs we use a set of ordered pairs in order to find a point. For instance, if I wanted to mark point K for Kino, we'll say it is 2 units down the x-axis and -3 units on the y-axis. Then this is the x-axis. And the first set of ordered pairs, 1, 2, and then -3. 1, 2, 3. So this is where point K is. All right. So that is a point. Now let's take a line. All right. So sometimes they will have a line on here on the plane, and they might want you to know or ask or define midpoints, distances between 2 points. There's a lot of things that we could do. So let's talk about the line. We need at least 2 points to make a line. So let's just say the origin is 1 point and point K is another point. Well, then the line kind of goes like this. Don't laugh at my artwork, guys. All right, so that is a line. And the arrows indicate that that line goes on for infinity. On and on and on. So, boom, we have the origin and we have and this is a negative slope. Now, if our line, and as we're scanning from left to right, appears to be going upstairs, this is a positive slope. If the line appears to be going downstairs, then this is a negative slope. And a lot of times, you'll either have a graph like this, or you will have a linear equation. And sometimes you just got to look at that linear equation, and you're supposed to be able to tell certain things about a particular line. For instance, let's deal with the positive and negative. Well, let's give you one linear equation. Y is the dry erase marker, so light. Y equals mx plus b. Now, when you see this form, don't go crazy. Like, I don't understand. Hey, Eliana, how are you? You know, when you see this form, don't go like, oh, I don't understand. Just, you have to understand. This is just a form. When they make these formulas, they just kind of like, all right, this is like a baseline. So, a good example of y equals mx plus b is y equals 2x plus 1. Y equals 2x plus 1. That is a good example. See how that's 1. That one's done in 2. All right. So y equals mx plus b. So this is in what we call slope-intercept form, or y equals mx plus b form, because we are given a slope, which is 2 over 1, and we are given a point where it crosses the y-axis, and we call this the y-intercept. So I know that sounds like anytime engineers or mathematicians, they get together, they make these words like that other people don't understand. So y, we have our y, mx, slope times x, plus b, which is 1. So this is the y equals mx plus b form. All right. And sometimes we may need to convert a problem into the y equals mx plus b form, because until you have a single y here, you're not in y equals mx in the y equals mx plus b form. All right. The other form, and again, I'll reiterate, this is the slope-intercept. Slope-intercept. S-L-O-P. Intercept form. The other form that this line could be in is a standard form. And I'll put the standard form here. And the standard form looks like ax plus by equals c. Again, don't go nuts. This is just the baseline. All right, it's just the baseline. So this is what we want it to look like. Like we have this looking like y equals mx plus b. Well, this just means the x value plus the y value equals, and then the number. So this would be 2 coming to the other side becoming negative. So negative 2x plus y equals 1. And now it's in standard form. All right. So it is very, very important to look at these and know how to go back and forth from slope-intercept to standard form. Because sometimes they may just give you this in standard form, and you're like, oh man. And they'll be like, okay, which one of these is the graph of this line? Well, you don't know. You have to change it into y equals mx plus b form, which is here. And what does this tell us? Just by looking at this line. This tells us that we have a slope of 2 over 1. Again, it's the slope-intercept form. Boom, boom. All right. And it's going to cross at positive 1 on the y-axis. So positive 1. All right, so we're at 2, 1, 2, 1. And it would probably look something like this. But it would be going upstairs. All right. But definitely crossing the y-axis, the vertical number line, at plus 1. All right. And I know I'm a little off in my artwork, but I did mark positive 1. All right. So you got to be able to see these linear equations and be able to visualize. Like, okay, this slope is 2 over 1. It's positive, so it's going upstairs, and it's going to cross the y-axis, which I kind of got a little bit close to the origin at 1. All right. If it was negative, all right, like so let's say this was a positive 2. All right. When we get ourselves into, and let me just wipe this guy out and redraw lines. All right. So when I get this guy back into slope-intercept form, it will be y equals, this will jump the fence and become negative 2x plus 1. All right. This is the slope-intercept form. This is the slope. It's negative. So it's going to be going downstairs, all right? And it will probably look something like, all right, let me try to get my there we go. That looks a lot better. All right. So the slope would look like this. If I'm looking at this line and slope intercept, it is negative, and it crosses 1, the y-axis at 1. This is the slope. This is the y-intercept. All right. So is that gelling for you guys? Does that, I'll wait because I know there's a time delay. And while we wait, I will glance at my email. There we go. Very good. All right. Okay. Now, what we're going to do is we got to check the question. And, oh, I forgot to shout out Steven. Steven just passed the aviation selection test battery. And I spoke with him, and he said, his recruiter talked to his boss and told him to go ahead and start putting the paperwork through. Working with me, he raised he took it the first time, didn't do too hot. But then when he worked with my program, he raised his score like 9 points. So that is a huge, huge jump. Huge. Like Donald Trump. Huge. It's huge. All right, shout out to the president. Huge. I like doing that. Like him, huge. All right, I'm getting caught up in that. Let's stop. So yeah, Stephen qualifies to be a student naval aviator or naval flight officer. He boosted his score 9 points, and so congratulations, Stephen. All right, where am I going? Okay. This is what we're doing. We're going to deal with Ileana's question. And we'll come back to linear equations. All right. Course. Oh. Why is it so small? I'm trying to, oh, there we go. There we go. Number 2. All right. Okay, so here's how the question reads, ladies and gentlemen. And this is how I would approach it. I'm telling you, if I was tested, I would approach it just like this. A passenger plane made a trip to Las Vegas and back. So I write my departure point, where I'm going. We're going there, and we're coming back. On the trip there, it flew 432 miles per hour. DRT for distance, rate, and time. DRT for distance, rate, and time. So on the trip there, it flew 432 miles per hour. And on the return trip, it went 480 miles per hour, 480 mph. How long did the trip there take if the return trip took 9 hours? So I'll put 9h. All right, so I have 2 pieces of puzzle. I only have 1 piece of the puzzle, of the distance, rate, and time puzzle here. So again, we can multiply. We can find the distance by multiplying the rate times the time, because our formula, distance equals rate times time. I will say that till I'm blue in the face. So what we're supposed to do is we're supposed to multiply 480 times 9, but I'm not going to do that. I'm going to multiply 48 times 9 and add a 0 later. So 72, 37, 36, 43. Now we have to add 0 back if we do it my rapid way. So the distance is 4,320 miles. So now, if the distance back is 4,320 miles, then the distance there is also, because it's point A to point B. So the distance is the same. Like, don't trip. The distance is the same. And we'll come to the end here where we have our distance and time. So we have two pieces of the puzzle, and we have to come up with the third piece. Now, the cool thing about this is the difference between the distances and time. And the time is a 0 being added, which tells me that this was multiplied by 10 in order to get 4320. So our answer is 10 hours. 10 hours. And Ileana, I guess you could scroll down and tell me if I'm right. Okay. All right. So, does everybody understand the process? I diagrammed my whole thing. Trip there and back. We flew 432 miles back. There, 480 back. And 9 hours. That was the information that was given to us. We multiplied rate times time and got 4,320. And that was our distance from point A to point B. Since the distance coming back from point A to point B was 4,320, the distance there was 4,320. We were given in the question a rate that we were flying there, which was 432 miles per hour. And all we had to do was divide, and we accomplished that in 10 hours. All right. Questions. Okay. All right. So we answered that. I just checked the email. So we'll touch on another topic on linear equations. All right. So what we established before was we have two different forms of linear. I cannot pronounce that word tonight for some reason. Linear, nuclear, linear equations. All right. So y equals mx plus b is a very interesting form. It is a slope-intercept form, but we can do a lot with it when we want to find a line. All right. Again, let's say we said y equals 2x plus 1. Again, we'll work with that one. So I could do a couple things with this. First, we need to understand that the slope, or m, is equal to rise over run. If it's positive. If it's negative, it'll be fall over run. What does that mean, Kino? Well, in this case, it's positive, so 2 over 1. Rise over run. So that means we're going to go up 2 points for every 1 point that we run. Rise over run. All right. Now, another thing we can do is we can make a table so we can show ourselves what this line looks like. So we go to the side, we make a table. All right. We have x and a y value. So just like we work our equations, what we do is we can plug in information. All right, so I like to do 0, 1, and -1 because that gives me both sides of the origin. So what we're doing in each case, we're just plugging in these values, 0 and then 1 and then -1 for x, and it's going to come up to a y value. So we'll have our ordered pairs. So to start off, if we have 2 times 0 plus 1, we're just going to have plus 1. All right, so boom. All right, and then we try the 1. 2 times 1 plus 1 equals what? 2 times 1 is 2, plus 1 is 3. So 1 and 3. And then negative 1. We're going to put in negative 1. I just put a little negative pip in there. All right, so negative 2 plus 1 is negative 1. All right. So we input negative 1 for x, and after we work out the equation, it gives us the y value, because on the other side of this is y equals. So at the end of the day, y is equal to 2 times negative 1, which is negative 2, plus 1, which is negative 1. So we can kind of get our own points. We don't have to use their points. We can make our own points. Yeah. All right, so here is our x and y axis. So 0, 1, positive 1. That's 1 point. 1, 1, 2, 3. Here's another point. And then negative 1, negative 1, which is right about here. And if you see, these kind of just all line up together. I mean, minus my little bad artwork. So again, y equals 2x plus 1. When we look at this in slope-intercept form, the line penetrates the y-axis at positive 1, and the rise over run is 2 over 1. Any whole number is really itself over 1. So let's see if this is true. So we're here, 1, 2, 1, 1, 2, 1. It is definitely doing that. So it is rising 1, 2 points, running 1, 2 over 1. Rising 1, 2 points, running 1. Again, rise starting here at negative 1, 1. We're going to rise 2 points, 1, 2, run 1. Boom. Rise 2 points, 1, 2, run 1. Bang. All right. So rise over run. That's what the slope means. All right. Is that gelling for you guys? Cody? It's okay. Practice makes perfect. And you know I have a lot of math questions. Tons and tons and tons. All the math you can eat. Right. But a lot of people, they don't understand linear equations, and they kind of just lose it. Like, I don't understand this. So, I mean, I encourage you guys over the next couple weeks and in the future to send on those questions. Okay, we have another question in. 2 children weighing 60 and 80 pounds respectively balance a seesaw. How many feet from the fulcrum must the heavier child sit if the lighter child is 8 feet from the fulcrum? So Cody and Ileana, what class lever system are we talking about when we talk about a seesaw? Type it in. I'll wait for the delay. What class lever system are we talking about when we talk about first class? Do you agree, Ileana? Okay. And you're both right. It is a first-class lever system. And while we're here, for video's sake, we have a fulcrum. If I could spell F-U-L, fulcrum, in a plank. And we have a load being applied and an effort being applied. The class 2 lever system, the load will be applied here and the effort will be exerted upward. All right, and the difference between a class 2 and a class 3 lever system is the effort and the loads change position. So since we're talking, for video's sake, since we're talking about class 1 lever systems, well, what does he mean? And are there any other types of class lever systems? So I've just indicated or documented that in the video. All right, so but what we're dealing with is the first class lever system, and it has a balance point or a fulcrum in the middle. There's another name for it. Can't remember right now. So back to the question, line by line. All right, so 2 children weighing 60 and 80 pounds respectively balance a seesaw. So how many feet from the fulcrum must the heavier child sit? If the lighter child is 8 feet from the fulcrum. All right, so the lighter child, 8 feet from the fulcrum. All right. So the 60-pound child is 8 feet from the fulcrum. And we're going to put this 80-pound child somewhere along here in order to balance out the system. All right. So, look at this. The fulcrum is the equal point, like an equation. And whatever's on, if we're going to have balance, what the load moment we produce on this side will have to equal the load moment we produce on this side. Now, what's a load moment, Kino? What's a load moment? All right. If we multiply 60 times 80, we will get 480. But we will call the units foot-pounds. Foot-pounds. That is the load moment. The load moment is weight times distance away from the fulcrum. And we get 4 pounds. So 480 foot-pounds is being produced on this side of the fulcrum. Why do we have that equal sign? Because the same thing must occur on this side when we multiply the distance and the weight together. So all we need to do is just multiply. And the cool thing about these is if you have this and this, which is weight and distance, and you only have one thing here, all you got to do is divide. So the answer is 6, because 480 divided by 80 is 6. You can use your calculator if you don't believe me. So boom, this is where we're going to put the 80-pound child. The 80-pound child is going to be 6 feet away from the fulcrum, and 80 times 6 is 480, and this is the amount of foot-pounds. So we have 480 foot-pounds on this side, 480 foot-pounds on this side. One thing that I need you to note is that the lighter child, although the child is lighter, it sits out further away from the fulcrum, 2 more feet, in fact. All right. So it has to be out. You know, when you have maybe like a larger child here, like in the center, you can get a smaller child and just put him out there, but he's got to be further back because the weight exerted here or the load moment exerted here is a function of distance times the weight. And it is so in that case with the 60 times 80. So that was a really good question. And I just need to know if you guys understood it. Maria, long time no see. Okay. So, Cody, did you understand that? Was it clear? You know, I can, all day long, I can solve problems, but that does not mean that it is clear. And, all right. Good. All right. Oh, and hit the like or dislike button, people. All right. So, what else did I want to touch on? On linear equations. We showed how to apply the linear equation. In testing, sometimes they will test your ability to find out where two lines intersect. All right. And this is the system of equations. It's really not that bad. What we're doing in this case is solving for two equations simultaneously. This is like linear equation night. Okay. All right. Give me a sec. I want to find a good. All right. Give me a moment, folks. Two computers, just gets tedious sometimes, folks. All right. All right. Not you. Okay, this should do it. That didn't do it either. Wow. All right. I apologize, guys. There we go. There we go. Good. All right. So, in these cases, why do you keep doing it like that? All right. No problem. No worries. All right. So we're going to have two equations, and y equals 7x minus 10, and then y equals negative 3. Now, this is an equation of a line. I know it doesn't look like it, all right, but it is. And so let's look at it. It is actually a horizontal line. All right, so in one sense, and like I said, when we plot, there is no x value. The x value is 0. So it's not going to float left to right of the y-axis. But at the y-axis, y is always going to be -3. 1, 2, 3. And so y is equal to 3, so it is a line that looks like this. This is what that line looks like. All right. This is a very steep line. 7/1 is the slope, but it's going to penetrate all the way down here at 3, 4, 5, 6, 7, 8, 9, 10. And -10 is the y-intercept, and the slope is going to be 7/1. So it's probably going to look something like this. All right. I'm just doing this by eyeballing it. So what we're trying to do is figure out at what point do these two lines intercept each other. Now, I guarantee you that the y value of the coordinate is going to be -3. Guarantee it. But we're going to see. So this is my prediction of what this line looks like. I just used my slope-intercept form. The slope is 7/1, and the y-intercept is -10, where one line crosses that, and then one is just a horizontal line. So let's do it. All right, so y equals mx plus b. This cannot be in this form if we're going to do a system of equation. We have to change the standard form. So we will have -7x plus y equals -10. And then this will just be y equals -3, as you see it here. We can't change it into a standard form because it is just an equation of like a horizontal line. So y equals -3. The x value is 0. All right, let me just make sure. Y-axis -3. All right. So basically what I'm going to do is I'm going to add downward. That's what I call it. All right. So y. Actually, you don't even need to do that because we already have a definition. Y equals -3. All right. If we had two standard form equations, then we would have to do that. But since y equals -3, then we just plug in -3. So for y, so we're going to say -7 times x plus -3 equals -10. All right. Now, I've taken this and put it into the y value because y equals -3, and then we're going to solve for x now. So -7x minus 3 equals -10. -3 is going to jump, so -7 x is equal to, this will become -7. So x is equal to 1. So our x coordinate is 1, and then -3 is the y coordinate. So this is where the two lines, and it is where I predicted it to be about, which would be 1 and then 1, 2, 3 down, which is here. So this is where these two lines intersect each other. Now, don't let that scare you. All right. The guys that I do work with, I will, address this one-on-one, but this is just a baseline of something you can look at because a lot of you guys are not understanding. They're not understanding linear equations and, slope-intercept form and how to look at a particular equation and know what it's supposed to look like on the graph. There's a disconnect. So blame the public school system. I'm just kidding. Just come here. I'll help you figure it out. So again, we are 5 minutes away from our close, and I also always use the last 5 minutes just to talk to you guys and let you know that, hey, now last week I had some internet issues, and so there's nothing I could do about it. I tried to come on, I couldn't come on. Then, like an hour and a half later, then, it was fixed, but it was too late because you guys are expecting me at 9 to 11. So I'm here every week. All military aptitude tests. ASVAB, AFOQT, OAR, SIFT. Did I leave something out? OAR, SIFT, ASTBE, ASVAB. Okay. And all Federal Aviation Administration pilot exams, from private pilot all the way up to airline transport pilot. The instructor class, initial instructor all the way up to multi-engine instructor, and then aviation ground instructor basic to advanced and instrument. So I've taken them all. Passed them, done really, really well. And if you are preparing for these exams, I want to show you how to do very, very well on the exam. So that's really about it. If my clients wish to do a Google Hangout, they can email me now at this point, and we will go right into the Google Hangout. But other than that, just meet me here every week. Unless I have some internet issue, I'm here every Friday. So go to stemwithkino.com. STEMKIENO.com. So science, technology, engineering, and math. That's what STEM stands for. All right. So, all right. Thank you guys for coming out. Please hit the like button if you like. Hit the dislike button if you dislike. And I will talk to you guys soon. Have a great evening, and I will see you next Friday. And getting all bougie now. I used to use my finger. Bye, guys. Yeah.